Task Manager isn't just a place to force close frozen apps. It's the most direct window into what your hardware is actually doing at any given moment. In this video, we'll look at how to use it to spot what's slowing your PC down and what to do about it. Before we open Task Manager, it helps to understand what it's showing you. Windows runs dozens of things at the same time. Your browser, background services, system processes, all competing for the same hardware. The kernel acts as the traffic controller, giving each one a time slice of CPU, a chunk of memory, and access to disk and network. Task Manager is your live view of that competition. When your PC feels slow, one of those resources is under pressure, and Task Manager shows you which one. There are at least two ways to open Task Manager. You can right-click the taskbar and select Task Manager from the menu, or use the faster shortcut, Ctrl plus Shift plus Escape. Once it's open, most people go straight to the Processes tab, but the real diagnostic work starts in Performance. Now let me show you practically. Right-click the taskbar and select Task Manager. Click on the Start menu, then start typing Task Manager in the search bar. And the fastest way to open Task Manager is by pressing Ctrl plus Shift plus Escape. The Performance tab is your first stop for any health check. The graph has two readings. The line at the top is usage intensity. It shows real-time load, what your hardware is doing right now. The shaded area underneath is consumption, total resource usage over the last 60 seconds. Check the left panel first. CPU, memory, disk, and network are all listed. Start here before going to individual processes. The default CPU graph shows an overall average. The problem is that average can hide something important. A single core being maxed out while all the others are idle. To see this, right-click the CPU graph, go to Change Graph to, and select Logical Processors. You will see every core individually. If one is consistently at 100% while the others are low, you're dealing with a single-threaded task bottleneck. Click Memory in the left panel. The key number is in use. That's how much physical RAM is currently occupied. When in use approaches your total RAM, Windows starts using virtual memory. It moves data from RAM onto your disk to free up space. The ceiling effect is what you're watching for. When the in-use line approaches the total, the system will start to choke. Disk-based memory is significantly slower than physical RAM, which is why a PC with full memory feels sluggish, even when CPU usage looks fine. The graph at the top shows memory usage over the last 60 seconds. The flat line tells you the pressure has been consistent, not a sudden spike. Cached is memory Windows is holding on to for apps you've used recently. Paged pool and non-paged pool are small reserved areas the system kernel uses. Available is your rail headroom. And the memory composition bar shows how that total is divided at a glance. No single number tells the whole story. Together, they tell you whether memory is under pressure or just busy. If your PC feels slow, but CPU usage is low, look at Disk next. The slide shows exactly this scenario. CPU is flat, but disk is hammered and Ethernet is saturated. Background updates and large file syncs can occupy your storage completely, leaving no bandwidth for your apps. The same applies to network. If something is transferring data in the background, everything else slows down while it waits. Switch to the Processes tab. It's normal to see 80 or 90 background processes listed. These are the silent services that keep Windows running. You're only actively using the apps at the top under the Apps section. To find what's consuming the most resources, click the CPU or memory column header to sort. The highest consumers rise to the top instantly. Click Memory to sort. Chrome and Edge are leading here, which is typical. If an app is frozen and won't respond, select it in the Processes list and click End Task. For anything you recognize as a user app, a browser, an editor, a game, that's generally safe. You will lose unsaved work in that app, but nothing else on your system is affected. The boundary to respect is between user apps and Windows processes. System processes, services, and anything connected to Windows Update are doing real work in the background, sometimes writing to disk. Forcing one of those to stop mid-task can corrupt data or trigger errors that are harder to fix than the original slowdown. The practical rule: if you don't recognize the name, right-click and choose Search Online before you touch it. Most Windows processes are well documented, and a search online will tell you whether it's safe to end. The End Task button in the top bar works the same as right-clicking. Use whichever feels natural. Here I'm expanding Microsoft Store to show its child processes, then right-clicking to end it. Notice, Search Online is also available here. That's your first move when you don't recognize a name. If you're on a modern ARM-based Windows device, Snapdragon-powered laptops in particular, the Details tab has one column worth enabling. Right-click any column header, select Columns, and enable Architecture. This tells you whether each app is running natively as ARM64 or as an emulated x64 application. Native ARM64 apps run at full efficiency. Emulated x64 apps carry a performance cost. If a specific app feels slower than expected on an ARM device, this is where you check why. Right-click any column header, choose Select Columns. Scroll down to Architecture. Once it's added, every process shows whether it's running as x64 or ARM64. On this machine, everything is x64. That's expected on Intel and AMD hardware. On a Snapdragon device, you would see a mix. That's where this column becomes useful. A slow boot is one of the most common Windows 11 complaints, and startup apps are almost always the cause. Click the Startup Apps tab. Each app shows its startup impact: high, medium, or low. High-impact apps noticeably delay your boot. Right-click anything labeled high that you don't need running immediately and select Disable. The app still works when you open it manually, it just won't launch automatically at boot. Sort by status first to bring all the enabled apps together, then sort by startup impact to push the high items to the top. OneDrive is a good example. Right-click, disable, and it drops off the startup list immediately. It still works when you open it manually. Here's the short version. Check performance first, CPU, disk, and memory to find where the pressure is. If one core is maxed out, switch to logical processors. If in-use memory is near your total, you need either less multitasking or more RAM. Switch to processes and sort by CPU or memory to find the specific cause. Use End Task only on apps you recognize. Check architecture on ARM devices if one app is slow, and prune your startup list to cut boot time. Those 5 steps cover most task manager use cases without needing any third-party tools. If this walkthrough helped you understand what your PC is doing, subscribe to Libertechia for more practical Windows 11 guides. And if there's a specific tab in Task Manager you'd like me to cover in more depth, leave a comment. I'd like to know. Stay reachable, and I'll see you in the next one.